Indiana University East Department of Science, Oxyacids. Oxyacids are acids that have a central atom, each and then with O's and OH's bonded to each side. And these are various examples of oxyacids. So the difference here are the two different features that allow us to look at oxyacids. The first being the central atom. So this central atom is not oxygen or hydrogen. So here is nitrogen, and here in carbonic acid is carbon, and phosphorus acid, it is phosphorus here, and so on and so forth. Note, in any of these cases, the hydrogen atom is bonded directly to the oxygen. So in each case, in order for acid dissociation to occur, or acid ionization to occur rather, we will have to make sure that you're breaking an HO bond. So the bond strength is about the same, but what we're going to look at are the effects that changing the number of oxygen atoms and the identity of the central atom would have on the strength of the OH atom, as well as the strength of, as well as how well the conjugate base holds charge. So let's look at first at changing what the central atom is. Here, if you look here, we've changed from chlorine to bromine to iodine. And you can see that as you go from chlorine to bromine to iodine, the acid strength decreases. Okay, the pKa increases, so the Ka actually decreases as the electronegativity of the atom decreases. Why is this? Well, let's think about it. We've got to break an OH bond, and to do this, we are going to have to withdraw electron density from the hydrogen. The more electron density you draw away from the hydrogen, the easier it is for water to act as a base and remove this proton. And therefore, as the electron density, and therefore, as the electronegativity of the central atom increases, more of this electron density is withdrawn from the hydrogen, as you can see from these maps. More and more electron density, and therefore the acid strength is dependent on the electronegativity of the central atom in this way. Now let's look at what happens when we increase the number of oxygen atoms present. As you can see, the pKa decreases rapidly with the increase in the number of oxygen atoms when you have, in this case, and this is generally true. There's a couple of ways of looking at this. Firstly, you can see that the oxidation number increases as the number of oxygen atoms present increases. And therefore, if essentially the amount of positive charge on the chlorine, the central atom, increases as you go down here. And that allows more and more of the electron density, draws more and more of the electron density away from this OH group. And as you draw away more and more of this electron density from the OH group, you will strengthen the acid, because it makes this more and more lose more and more electron density, making it easier to pull off. Another way to think about this, actually, is the relative stability of the conjugate base. So here, as you go down, there's more oxygen on the conjugate base, and so the anion, this conjugate base becomes more and more stable, and as the stability increases, of the anion increases, it becomes easier for the acid to dissociate and therefore increases acid